So these are the transmitter and receiver modules. The smaller one is the transmitter and the bigger module is the receiver. They both operate around 433 MHz, which is written on these crystals. These modules also come with 4-bit encoder-decoder ICs. Let's start by learning about transmitter module. As you can see, it is a 4-pin module starting from the first pin, which is an antenna. It can be a simple 7-inch wire or an extendable antenna. Coming to the second pin, which is a VCC, we usually give here 5 volts, which can be a USB power supply or a normal regulated power supply. The third pin is the data in pin, to which we'll be connecting the data from the encoder IC. The last pin is the ground pin. As I've already mentioned before, the module operates at 433 MHz. You can tell the frequency by reading the value over the crystal. Here it says 433, which means the crystal is operating at 433 MHz. Now let's see the receiver. The receiver basically has 8 pins, and most of them are common pins. As you can see, the module has 3 ground pins, 2 VCC pins, 1 antenna and 2 data pins. Any of the single pins can be used from them. Here the data out pin is connected to the data in pin of the decoder. For the antenna, like the transmitter, we'll be using a 7-inch long wire. This receiver module also comes with a 12D decoder IC. It's an 18-pin IC containing 9 pins on one side and 9 pins on the other side. The first 8 pins are the address pins. The data at the transmitter address pins should match the data at the receiver address pins. Only then the data will be transmitted. Say for example, if the transmitter side has all zeros, that is, all pins grounded, then the receiver side should also have all pins grounded. Similarly, if all transmitter address pins are ones, then all receiver address pins should be ones. Only then the data will be transmitted properly. With the help of these address pins, you can control multiple receivers with a single transmitter. Next, the data out of the receiver module is connected to the data in of the decoder IC. This helps to take the data coming from the receiver module and decode it. The remaining connections like the VCC, ground, everything remains the same. As you can see, there is a 51 kilo ohm resistor connected at the 14th pin. The 9th pin is a ground pin and 10 to 13 pins are the data out pins. Whatever data is received in serial from the receiver is converted into parallel here. To monitor this, you can simply connect an LED or give it to some other circuit as input. The 17th pin is an indicator of transmission. So if you connect a simple LED there, whenever there is a data transmission, the LED starts blinking. Similar to the receiver, transmitter also has a very simple circuit. As you can see, the encoder IC used here is 12E, E for encoder, like the 12D, T for decoder used for the receiver modules. So the IC has a similar configuration like the receiver decoder IC. Here the data out of the encoder is given to the input of the transmitter module. It has 8 address pins, 9 pin is a ground, 18 pin is a VCC and 17 pin is the data out pin. Here 10 to 13 pin are the data in pins, where we can simply connect the pin to the VCC using a switch to give it a logically high value, and grounding the pin will give as a logical low. So to give 0 we'll be grounding the pin, and to give 1 we'll be connecting it to the VCC. As already mentioned before, we connect the data out of the encoder IC to the data in of the transmitter module. Similar to the receiver, we can use a 7-inch long wire for the antenna here as well. So as you can see, I have connected both the circuits on two different breadboards, so that it will be simpler for me to move the breadboards away and measure the distance. I'll be using a USB cable to power these circuits. This makes it flexible to connect to a USB power supply or a power bank. For the antenna, I'm using this 7 to 8 inch long wire wound in the form of a spring. This would reduce the space used by the antenna. Now I'll power up the receiver. I'll connect the USB cable to a power bank. As you can see, the LEDs don't turn on, even though the power bank is connected. Now I'll turn on the transmitter. As you can see, the LEDs start switching on once the transmitter is connected. Just for testing purpose, I have kept the transmitter and receiver at some distance, and when I switch on the transmitter, you can see that the blue light on the receiver at the 17th pin starts glowing, indicating that it's receiving the data. Now I'll slowly change the data at the transmitter, and you can see that the receiver data also changes. Now you can see that one of the LEDs switched off and 3 are glowing, indicating the data as 0111. Now it's 0101. So as I keep changing the data at the transmitter, the data at the receiver keeps changing, indicating successful transmission of data. So this is how you can use this RF transmitter and receiver module to transmit 4-bit data across the room. I have tested the transmission distance to be close to 10 meters inside the room, and it can be a lot more outside. So that's all for today's video. If you like this video, you might like some of my other videos too. Please check them out at Electronics Made Easy Khadir. Till then, I'll see you in my next video.